Good day everyone. So my task here is to report to you the plate number 13 problem number 2. We have here a one-way slab having a simple span of 3.5 meter and has a thickness of 125 mm. The slab is reinforced with 12 tension bars with the Fy equals to 415 MPa and space at 130 on the center. We're going to determine the additional live load the slab can carry if the existing load is 2000 Pascal. Then we need to use the value of Fc prime as 21 megapascal. Considering a 1 meter strip of slab which is B equals to 1000 mm or 1 meter, we need to identify first the uniform floor pressure to be carried by the slab. And since live load is already given in the problem, we only need to determine the value for the dead load. So we have here the formula for the dead load, which is weight of the dead load equals the unit weight of concrete times the B, which is the 1 meter strip of the slab, times H, or the slab minimum thickness. We will be using a 24 kilonewton per cubic meter for the unit weight of concrete since it is a reinforced concrete. So we have the value of the dead load as 3 kilonewton meter. Next is to compute the effective depth of the slab using the formula D equals to H subtracted by the covering, and since there is no value given for covering, we will be using the usual 20 mm concrete cover of the slab and then subtracted by 1/2 of the diameter of the main bar. Substituting all the values, we obtain the value of the effective depth as D equals to 99 mm. Next step is to calculate the steel area, for we will using this value in determining the required steel ratio. So we have here the formula AS equals to 1000 divided by S times the bar area. Substituting the values, we obtain the steel area value as 869.98 mm squared. Now we can solve for the value of the required steel ratio. We have here the formula ρ equals to AS divided by B times D, and substituting all the values, we obtain the value of steel ratio equals to 0.00879. So to know if the steel yields, we need to determine the value of balanced steel ratio. So we have here the formula ρ equals to 0.85 times Fc prime times beta 1 times 600 divided by Fy times the quantity of 600 plus Fy. And then substituting all the values, we obtain the value for the balanced steel ratio as 0.0216. And since the balanced steel ratio is greater than the required steel ratio, therefore the steel yields. So now we have to determine the value of the coefficient of resistance, but before that we need to solve first this value to obtain the value of the coefficient of resistance. We have here the formula omega equals to ρ times Fy divided by Fc prime, and substituting all the values, we obtain its value of 17370. So by that we can solve the value of the coefficient of resistance with the formula R sub n equals to Fc prime times omega times 1 minus 0.59 omega, and we obtain the value of the coefficient of resistance as 3.274 megapascal. Next is to determine the factored moment or the mu, and in determining its value we have here its formula mu or m sub u equals to phi times r sub n times bd squared. Then substituting all the values, we obtain the value for the factored load as 28.88 kilonewton per meter. Now, we are going to solve for the value of the uniform load from mu. Using its formula, mu equals to W sub u times its length squared divided by 8. Substituting all the for all the values, we obtain the value of the uniform load as 18.86 kilonewton meter. Now going back to our problem, we have here is to determine the additional live load of the slab can carry if the existing live load is 2000 PA. So our additional live load here is unknown. Therefore, we need to assume that X will be our additional live load here. So using the latest code of load factors, we have here the equation of W sub u equals to 1.2 times weight of the dead load plus 1.6 times the weight of the live load. Substituting the values and rearranging the equation, we obtain the value of the additional live load as X equals to 7.54 kilonewton per meter. So that would be all. Thank you and God bless.